Okay, we are going to talk about the solution of this paper. For first question, sine 360 degree minus theta times cosine 90 degree plus theta plus 1. Okay, you need to simplify this. As you can see, there's an MC questions, so we can use the MC technique called method of substitution. That is, you try to substitute theta equal to certain value, for example, 10 degree, then you can calculate the expressions. So that's sine 350 degree minus 1 times cosine 100 degree plus 1. Then you can get the value by using calculator. So sine 350 degree minus 1 times cosine 100 degree plus 1, that is negative 0.969846 something. After you find the value of the expressions, go to the option A, B, C, D, you substitute theta equals 10 to each of them. For example, in part A, negative cosine square 10 degree, but actually means negative cosine, you take 10 degree first and then take square. And if you put it in the calculator, luckily you will find the answer is the same. So you can make the conclusion that A is the answer. But of course, there's some reminders. First one, if you want to play safe, you need to check the choices of B, C, and D also. Check all choices. Okay, second reminder, that is, do not use some special values. For example, some of you use 0 degree, 30 degree, 45 degree, 60 degree, or 90 degree. These are not suitable because it will match some answer occasionally. So you are not suggested to use these special value. Okay. Now go to question number 2, and theta lie within 0 degree up to 360 degree, including two ends. Okay, including two ends. So how many roots does the equation 2 sine square theta equals 1 have? Look at here. In this equation, the variable is theta, not cosine theta. Some of you just look at, oh, this is similar to the quadratic equation with something degree 2. So circle answer A. That's not true. The question with the variable theta. So the question is asking how many value of theta will satisfy this equation. So let's solve this one by one. 2 cosine square theta equals 1. So cosine square theta, that's 1/2. So cosine theta will be positive 1 over root 2 or negative 1 over 2. And you can see that if cosine theta is positive, that means it lies on the first quadrant and fourth quadrant. And you know that the reference angle of cosine theta could be found by using calculator. Shift cosine 1 over root 2, that's 45. So the first answer will be 45 degree. And the second answer, since it lies on the fourth quadrant, so there's a reference angle 45 degree, and the answer you need to get is this one, the reflex angle 315 degree. So you have two answers here. And second, look at this equation. If you need to solve the equation cosine theta equals negative 1/2, you know that theta lie on second and the third quadrant. Next, you need to find the reference angle again. Similarly, if you need to find the reference angle, you do not need to input the negative sign. Just obtain the value, the acute angle value. That is 45 degree again. But the final answer is, that is 45 degree. In the second quadrant, you need to take it is 135 degree. For the third quadrant, the angle is here. You measure this angle is a reference angle. So the final answer is starting from the positive x-axis, move to here, 225 degree. So in the second equation, you get these two answers. And therefore, totally 1, 2, 3, 4. You have 4 answers. Answer will be C. Go to the third one. For this question, you need to find the length of PQ. First of all, you can use angle sum of triangle to find this angle is 85 degrees. So by using sine rule, PQ over sine 40 degrees will equal to 10 over sine 85 degrees. Then you can find PQ, that is 10 times sine 40 degrees over sine 85 degrees. That's the answer you can get. So B will be your answer. And then go to question number 4. In this figure, you need to find cosine theta. Since three sides are given, so you can apply cosine law directly. Cosine theta, that is 7 squared plus 9 squared. These two sides will form the angle theta, so we add these two lengths together and then minus the opposite side, okay, with the square, over 2 times 7 times 9. You just need to simplify this fraction, okay? So that is 7 squared plus 9 squared minus x squared, and then over 2 times 7 times 9. You get the fraction that is 11 over 12. Cosine theta equals 11 over 21. Okay, not 12, 21. That's the answer. And next, for question number 5, you need to find the area of this triangle. Since you can see that this is the triangle with three sides given, this is a very big hint for you to using Heron's formula. Find the half of the perimeter. That's 9 plus 10 plus 11 over 2. So what will you get? 15. And then find the area. That is 15 times 9 minus 9 times 15 minus 10 times 15 minus 11. That's the Heron's formula. Apply it directly, you get square root 1800. So the answer is C. And for this one, the area of triangle is 12. You need to find value of theta. Theta is it is obtuse angle. That means that's line between 90 degrees and 180 degrees. So you can set the equation. 1/2 times 8 times 6 times sine theta will equals to 12. That's the equation you can set up. So sine theta, that is 1 over 2. The problem is you need to find theta. So you can substitute in A, B, C, D, these four answers into the equation to find which one will satisfy the equation. Of course, A and B are not the answer because these two are acute angle. So you substitute C inside the equation, sine 120. That's not 1 over 2, so C is not the answer. Finally, sine 150 degree, luckily, that is 1 over 2. So D is the answer. And move to question number 7. The figure shows the graph of y equals k times sine bracket x plus 30 degree. K is a positive constant. Suppose the graph, this one, okay, passes through A, 0 degree 1, pass through this point, and the horizontal line, the dotted line you can see, passing through A will cut the graph at B and C also. Find this coordinate. So what you need to do is find K, and you can substitute x equal to 0 degree, y equals 1 in the equation. So 1 equals K times sine 0 degree plus 30 degree. And you will get K times 1 over 2 equals 1. So K is 2. Now you need to find B. Again, you can look at this point B. You did not know the value of x coordinate, but you know the y coordinate is 1 again because it's a horizontal line. So 1 equals 2 times sine bracket x plus 30 degree. So 1 over 2 equals sine bracket x plus 30 degree. The point is you need to find x. So you try to substitute the number inside to make it become 1 over 2. So what is x? As you can see, if you substitute 90 90 plus 30, that's 120. So sine 120 degree is not 1 over 2. How about 120? When you substitute x equal to 120 plus 30 degree, yes, you can get 0.5. So x will be 120. And you know that x coordinate is 120 and the y coordinate is 1. So the answer is D. And then go to question number 8. This is a rectangle PQRS. So many right angles here. T is a point line on PS. Find RT over PR. Like it seems difficult at the beginning, but when you consider the triangle PTR, it will be quite straightforward. First of all, this one is 90 degree plus X. And second one, this is 90 degree minus Y. So when you consider this triangle using sine rule, RT over sine 90 degree minus Y will equals to PR over sine 90 degree plus X. So PT over PR will equal to sine 90 degree minus Y over sine 90 degree plus X. And what is sine 90 degree minus Y? That is cosine Y. Sine 90 degree plus X, that is cosine X. So the answer is B for boy. Or you can see that even though you don't know how to simplify the denominator, just look at the numerator, sine 90 degree minus Y, that's cosine Y. So you can get the answer B divided by something. Cosine Y divided by something. So answer should be B. Then you can find the answer by using the logical deduction, okay? So go to question number 9. A, B, C, D, E, F, G, H is a cube of sine 1 cm, and theta will be the angle between diagonals BE and the face EFGH. You need to find tangent theta. The main problem is you need to define where is theta. That is, starting from the diagonal BE to the face EFGH, the intersecting point is E. So move to another end of the line segment, B. You need to project B to the face EFGH. That's G. And hence, you can add this line. This is theta you need to find out. Okay? And tangent theta, actually that is BG over GE, right? So how do we find BG? That is 1. And GE, look at the right angled triangle here at the face EFGH. You can find GE directly by using Pythagoras theorem. So that is 1 over root 2. So the answer is A. And then go to question number 10. It's so the right pyramid. Okay, that means when it mapping on the ground ABCD, it will move to the center of the square. Okay, AB is 10, VD is 13. Find the angle between VB and the face ABCD. Again, you need to know this is 13 again. 10, there's a square. You need to find is from point V mapped to the ground called as M. So this is the angle you need to find out. How to do this? First of all, you can find BM, that is square root 10 square plus 10 square, that is BD, but you need to take half only times 1 over 2. So you can get BM, that is 5 root 2. And how do we find the angle here? So you can use cosine theta, that is BM 5 root 2 over BV, that's 13. And you can press 5 times root 2 divided by 13 and then shift cosine. Then you can get 57 point something. So the answer would be C. The quite straightforward question. And go to question number 11. In this figure, QRST is a rectangle. That means, okay, all these angles are right angle. And PT is perpendicular to the face QRST. Look at this one. That means P is vertically above T. Now what you need to do is find the right angle. PRQ is not a right angle, okay, because there's a triangle, okay, that is the acute one. So B is the answer. Why? Because this forms the right angle and T can moving up to P, so by free perpendicular theorem is also right angle, okay. So the answer is B. Final question number 12. This is a tetrahedron VXYZ. Suppose angle YXZ is 90 degrees, mark it here, and you quickly know that it's 5 meters YZ by using the Pythagoras theorem, simple. And V is vertically above X. Now you need to find the angle between VYZ and XYZ. First of all, find intersecting line, which is YZ. And next, on each face, draw a perpendicular line perpendicular to YZ. We call it as K. So the problem is, if VK is perpendicular to YZ, can I join XK so XK also perpendicular to YZ? In this case, yes, because based on free perpendicular theorem, Vx is perpendicular to the face XYZ, and Vk is perpendicular to YZ. So when V is moving down, go down back to X, this line also perpendicular to YZ. And hence, the defined angle here, theta, that is angle VKX, that's the angle we need to find out. So how do we find this? We can use tangent theta. Tangent theta, that is 3Vx over xk. The problem is how to find xk. Just look at this right angle triangle, 3, 4, 5. Okay? But consider the area of triangle xk times 5 equals 3 times 4. Why? Because xk times 5 over 2 is the area of triangle. 3 times 4 over 2 is also the area of triangle. So xk, that is 2.4. And hence, you can substitute here, tangent theta, actually that is 3 over 2.4, then you can find theta. Shift tangent, start bracket, 3 divided by 2.4, 51.3 something. So answer is D for dog. So that's the end of the paper.